In this video, you will learn about trig identities and how to find their angles and apply them to trig functions. Eventually, you are going to be doing these four things: evaluating their functions, simplifying their expressions, developing additional identities from the basic ones that you will learn, and then how to solve trig equations with them. Now, there are 6 reciprocal identities: sine, cosine, and tangent. As a review, secant, cosecant, and cotangent are reciprocals of sine, cosine, and tangent. Sine and cosecant are reciprocals of each other, cosine and secant, and then tangent and cotangent. And we will be using those reciprocal identities in the future when we are simplifying those expressions. There are 2 quotient identities with tangent and cotangent. Tangent, it has the identity of sine divided by cosine, and cotangent has the identity of cosine divided by sine. Again, they are reciprocals, which is why the fractions are flipped. But one new thing, if you have not already learned it, is the tangent of an angle is equal to sine of the angle divided by cosine of the angle. Now, there are some things called Pythagorean identities. If you think about from the unit circle, whenever we want to get to this point, which is x, y, if you think of this in terms of x, in terms of y, and if you think of this as an angle, from the unit circle, we have learned that if you were to take the sine of this angle, it is going to equal y divided by 1. So therefore, we know that y is the same thing as sine of theta. Cosine of this angle is adjacent over hypotenuse, which is x divided by 1, which means x represents cosine of theta. So if we were to replace x and y with what x represents, which is cosine, and y represents sine, then we have a right triangle that we can actually do the Pythagorean theorem on. So the Pythagorean theorem states that a side squared plus the other side squared is going to equal my hypotenuse squared. And we know that 1 squared is just 1. So that is actually our first Pythagorean identity. Now that we have learned that sine squared plus cosine squared equals 1, we now can actually create other Pythagorean identities from this one. So for example, if I was to divide everything by sine squared, which I can do as long as I do it by each expression. Sine squared divided by sine squared is the number 1 because it cancels itself out. Cosine squared over sine squared is cotangent squared from our quotient identity. And 1 over sine squared is cosecant squared, again from our reciprocal identity. So we actually have now created a brand new Pythagorean identity from our original, that 1 plus cotangent squared is going to be equal to cosecant squared. So I'm going to take this and I'm going to move it as something. Now, there is one other one that you can also create. Instead of dividing everything by sine, if we divided everything by cosine squared, sine squared over cosine squared is the quotient identity of tangent squared. Cosine divided by cosine is 1, and 1 over cosine squared is the reciprocal identity of secant squared. So we have actually created 2 new trig identities from our original Pythagorean identities for trig functions. As a review, there's 2 different things called even functions and odd functions. Even functions state that if you were to place some value of x into a function, and then you are also to put in the opposite number. So like, let's say you put 2 into a function and you got 5. And then you put -2 into a function and you would actually still get 5. It would be considered an even function. So for example, like if I plug in 2 into this equation, I would get 4. So if I plug in 2, I would get an output of 4. But if I plug in a -2, I also will get an output of 4. And so this is considered an even function that if you put in a number and its opposite, you will still get the same answer. Odd functions do exactly what is the opposite of even. They do the opposite sign. So for example, in this case, if I was to plug in 1, I would get, let's just say 2. If I was to plug in 2 into this function, I would get 8. But if I plugged in -2, I actually would get -8. I get the opposite sign of the original number. That is even and that is odd, and we're actually going to use that in trig identities. So what we're going to do with those even and odd identities is we're going to actually put them to use with the unit circle. So let's start with cosine. If I was to take cosine of 30 degrees, which we now know that the xy coordinate is the cosine sign, so the cosine of 30 degrees is going to be square root of 3 over 2. Well, if I find the cosine of -30 degrees, now from a coterminal angle, negative means I am going in my opposite direction, which is the same thing as 330 degrees. So -30 degrees would be going this way, and the cosine of that, my x value, is still a positive square root of 3 over 2. So cosine is actually an even function. Sine at 30 degrees is 1/2. So if we were to take the sine of -30 degrees, which means we go in the opposite direction, the sine at that is actually a -1/2. So I change signs when I change signs of the input, I actually change signs of the output, which means sine is an odd function. So now, based off of sine and cosine, we can actually find what is even and what is odd based on everything else. So cosine and secant, which since secant is a reciprocal, they are even functions. If you place an angle and you place the opposite side of that angle, you would get the exact same answer. These are all odd, and the reason tangent and cotangent follow along with sine and cosine is because when you think of the quotient identity, which is sine over cosine, you have an odd divided by an even, and so your answer is going to be odd. So same thing with cotangent. Now there is also something called the cofunction identity. And so cofunction is basically where there is a time to where you can manipulate a sine function to actually output a cosine function. And so if you notice, for example, that the x value is square root of 3 over 2 at 30 degrees, but at 60 degrees, it is the y value function. So there's actually a time to where we can make a cosine become a sine function to where you actually output that exact same function. So for example, cofunction identities basically states that there is a way that we can manipulate a sine function to get it equal to a cosine function. And so this states that if you were to take an angle and you were to subtract it from 90 degrees, or pi over 2 if it's a radian, then the sine of that angle would actually equal the cosine of your original angle. So for example, let's say that theta is 3 pi over 2. So if I was to go ahead and determine cosine of 3 pi over 2, it would be 0 on the unit circle. Now, if I was to plug 3 pi over 2 into this cofunction identity, pi over 2 minus 3 pi over 2, that would equal sine of negative pi. And so if you were to go on negative pi to find the sine of that, you would also actually get the exact same answer, which is 0. And it happens for each one of these identities that if you were to divide by 90 degrees, it will actually give you what the angle is equal to of that function.